Hi friends, today I'll be discussing the reactions of potassium dichromate, which is K2Cr2O7, and potassium permanganate, which is KMnO4, in acidic, basic and neutral media. These reactions are very important from exam point of view. So let's discuss and learn the reaction of these two moieties in different mediums. Well, I'm writing oxygen trig here since we'll balance oxygen first of all in these reactions, and then we'll look for hydrogen and the charge. So potassium dichromate can be written as twice of K plus Cr2O7 2 minus. Now in the presence of acid, nothing basically happens to the potassium ion. Whatever happens with the dichromate ion. So we'll look for the reaction of dichromate in the presence of acid. So we just have to remember one thing, that dichromate ion gets converted into twice of chromium 3 plus ion in the presence of acid, and the rest we can balance accordingly. So first of all, we'll balance oxygen atom on both sides of the reaction. So here we can see that on the reactant side 7 oxygen atoms are present. So in order to balance the oxygen atom on the product side, we'll add 7 molecule of water. We have to add the same number of water molecules as the number of oxygen atoms are present on the reactant side. So we'll add 7 molecules of water on the product side. Now we'll look for hydrogen. Total of 7 multiplied by 2, that is 14 hydrogens are there on the product side. So we'll add 14 H plus ions on the reactant side, such that the hydrogen on both sides of the reactions are balanced. Now ultimately we'll balance the charge. So we can see that a charge of plus 14 minus 2, which is plus 12, is there on the reactant side, and a charge of 2 multiplied by 3, which is plus 6, is there on the product side. So in order to balance the charge, we'll put 6 electrons there on the reactant side, such that the total number of charge on the reactant side becomes plus 12 minus 6, which is equal to plus 6 on the reactant side, which is equal to the charge on the product side. So that's how we balance potassium dichromate in acidic media. Now let's look at the reaction of potassium permanganate in acidic media. Well, potassium permanganate can also be written as KMnO4 is equivalent to K plus MnO4 minus. Again, nothing will happen to potassium ion. Whatever happens with the permanganate ion. So we'll see how this permanganate ion reacts in the presence of acid. So again, we have to remember just small thing, that permanganate ion gets converted into Mn2 plus in the presence of acid, and the rest we can balance as we have balanced in the previous equation. So first of all, we'll balance the oxygen atom on both sides of the reaction. Here we can see that 4 oxygen atoms are there on the reactant side. So we'll add a total of 4 water molecules on the product side, such that the number of oxygen atom on both sides of the reaction becomes equal. Now we'll look for hydrogen. Well, we can see that a total of 4 multiplied by 2, which is 8 hydrogen atoms are there on the product side. So we'll add 8H plus on the product side, on the reactant side, such that the number of hydrogen atoms also becomes equal. And now we'll look for the charge on both the sides of the reaction. So a total of plus 8 minus 1, that is a total of plus 7 charges there on the reactant side, whereas a charge of plus 2 is there on the product side. So we'll add 5 electrons on the reactant side, such that a total charge on both the side becomes equal. So the charge on the reactant side becomes plus 7 minus 5, which is equivalent to plus 2, equivalent to the charge on the product side. So that's how we balance the reaction in the acidic medium. Now let's see what happens to the reaction. Now let's see what happens to these moieties in the basic medium. So we'll balance these two moieties in the basic medium by using the charge trick. That is, we have to balance the charge first of all, and then we'll balance oxygen and hydrogen atoms on both sides of the reaction. So we'll see that the dichromate ion gets converted into twice of CrO4 2- in the presence of base. This only thing we have to remember, that dichromate ion gets converted into twice of chromate ion in the presence of base. And then first of all we'll balance the charge. So we can see that a charge of 2- is there on the reactant side, and a charge of 2 multiplied by 2, which is -4, is there on the product side. So we have to place twice of hydroxyl ions on the reactant side, such that the charge on the reactant side also becomes equal to -4. Well, we are adding hydroxyl ions here, since hydroxyl ions are the identity for the basic medium. So now we'll look for number of oxygen and hydrogen atoms on both sides of the reaction. So here the number of oxygen atoms are 7 plus 2, which is equivalent to 9, and a number of oxygen atom on the product side is 2 multiplied by 4 is 8. So we have to add 1 molecule of water in order to balance the number of oxygen atom. So on adding the molecule of water, the total number of oxygen atoms on the product side becomes equal to 9, which is equal to the oxygen atom of the reactant side. Now we'll balance for hydrogen. So we can see that total number of 2 hydrogen atoms are there on the reactant side, and also on the product side the total number of hydrogen atoms are 2. So that's how we balance potassium dichromate in basic medium. Now we'll look the reaction of permanganate ion, that is potassium permanganate, in basic medium. So again we have to remember one thing, that permanganate ion gets converted to MnO4 2- in the presence of the base. So again, first of all we'll balance the charge. Well, we see here that a total charge of -1 is there on the reactant side, whereas a charge of -2 is there on the product side. So we'll simply balance the charge by addition of an electron on the reactant side. We are not adding any hydroxyl ions in this equation, since already the total number of oxygen atoms on both the sides are 4. So if we add hydroxyl ions, they might cause disturbance in the total number of oxygen atoms. That is why we can simply balance this reaction by adding an electron. Hence the total charge on both sides becomes -2, and thus the equation is balanced. Now we'll see how the reaction takes place in the neutral medium. Well, we'll balance this equation using the water trick. So I've written water here, since we have to add water on the reactant side, since the reaction is taking place in water neutral medium, that is water. So first of all we'll write this dichromate ion, and then we'll add water molecule to the reactant side. And one thing we also have to remember, that the dichromate ion gets converted again to twice of chromate ion. We have to remember that the dichromate ion is converted to twice of chromate ion, and then we can add water on the reactant side, and then we can balance for charge, hydrogen and oxygen. Now we'll look for oxygen first of all. Now we can see that a total of 7 plus 1, 8 oxygen atoms are there on the reactant side, and here also the total number of oxygen atoms are 2 multiplied by 4, which is 8. Now we'll look for hydrogen atoms. Total number of hydrogen atoms on the reactant sides are 2, whereas there is no hydrogen on the product side. So we'll balance by addition of 2 H plus ions on the product side. Thus the total number of hydrogen atoms becomes equivalent to 2, and thus becomes equal on both the sides. Now we can look for charge. Well, we can see that the charge on the reactant side is -2, whereas the charge on the product side is also 2 multiplied by 2, which is -4 plus 2 is equals to -2. Thus the charge is also balanced in this reaction, and that's how we balance this particular reaction in the neutral medium. Now let's look at the reaction of KMnO4 in neutral medium. So again, MnO4 minus, we have to remember one thing, that MnO4 minus gets converted to MnO2 in the presence of neutral medium, and then we can add water accordingly. Since on addition of water here, we can see that the total number of hydrogen atoms become 4 plus 1 is equals to 5, and here 2 oxygen atoms are present. So we have to make the coefficient of water molecule in such a way such that the total number of oxygen atoms on the reactant side are even. So if we add a coefficient of 2 here, the total number of oxygen atom on the reactant side becomes equivalent to 6. 4 plus 2 is 6. And now we can balance the total reaction by balancing the oxygen atom on the product side. So here we can see that 6 oxygen atoms are already there on the reactant side, and already we have 2 oxygen atoms on the product side. So we have to put 4 hydroxyl ions on the product side such that the oxygen atom becomes equivalent to 6 on both the sides. Now we can check for hydrogen. We can see that total number of hydrogen atoms on the reactant side is equivalent to 4, and total number of hydrogen atom on the product side is also equivalent to 4. So hydrogen is balanced, oxygen is balanced, and at the end we can look at the charge. So we can see that a total of -1 charge is there on the reactant side, whereas a total of -4 charge is there on the product side. So we can add 3 electrons such that the total charge becomes equivalent to -4 on the reactant side, which is equal to the total charge on the product side. So that's how we balance these equations in different media. I hope you like my video, and this video is also beneficial to you. So if you like my video, please like, share and subscribe, and thanks for watching.